Welcome to the technical tutorial for the metrology package. In this video, we will guide you through the first steps for effectively operating the software and creating high-quality 3D scans using the example of our multi-scanner calibration. Before we begin, make sure you have the AT solution package installed. The metrology package is included as a part of this. As usual, the tools can be found on the desktop and in the Windows menu after installation. If you haven't done this already, you can do this on our new website. The documentation provides you with an overview and much more information on the contents of the package, the examples, and the extrinsic calibration we talk about in this tutorial. Open the Metrology Explorer and load any offline example from our supplied datasets by clicking Open Script. By first use, it will automatically navigate to the metrology samples. These examples serve to show the possibilities offered by the metrology package. The multi-scanner calibration example shows how it can compensate for an offset between several scanners, as shown here with the dual head. The log below shows the executed operations and some measurement results. By switching to the script view, you can see how the code is structured. We will carry out this calibration process ourselves with a live script in the next steps. To do this, we connect the dual head to the Metrology Explorer. Click on Connect to display all available sensors. All sensors can now be selected for connection from this list. To make multiple selections, simply press and hold the control button. All connected sensors are now displayed as tabs in the left-hand area, and we can get started. For the first connection, the default settings are configured, so that you can start recording directly in the free run mode. The acquired scan is displayed directly as an intrinsically calibrated point cloud data and can be rotated, moved, and enlarged as a 3D object. The parameters will most likely need adjustments to the setup. In this case, we work with a linear axis, which supplies signals as a profile trigger via an encoder and outputs a digital output as a start trigger. We select in 1 for the object trigger and set the line trigger to encoder. The encoder divider and the line distance can be determined from the required resolution and the increment distance to the encoder. The length of the object can be set with this parameter. The sensor mount is now ideally coordinated with the transport movement of the axis. Notice, these reflexes are likely to happen if the exposure time is set to high. With the function of the multipart object reflectance, you can check in the scan whether the exposure time is set appropriately. The bright white is indicating in which areas the saturation is set to high. To fix this, you can adjust the exposure time with this parameter. The sensor settings now ideally fit the transport movement and the object surface characteristics. With the adjusted settings, a new scan can now be taken that corresponds to the desired result. With this scan, we now want to carry out a multi-scanner calibration because the point clouds provided by the two sensors do not align. For this purpose, the metrology package now also contains generic samples which can be tested with the scanner by making only small adjustments. A spherical target can be seen in the scan, and the file containing the coordinates of the sphere centers is absolutely necessary for this. You can find all information about the target and the product documentation. Open the multi-scanner calibration script from the generic samples folder by clicking on Open Script again. The following adjustments must now be made in the script. Note: the Metrology Explorer is not a tool for developing these scripts. For that, we offer our Metrology SDK. First, change the path to the file where the sphere coordinates are located. The next step, we fill in the radius of the spheres on the target. This integer value is set in millimeters. The last step, we have to modify the path where the calibration matrix file is stored. Once all adjustments have been made to the script, another scan can now be recorded. If a script is loaded in the Metrology Explorer, it is applied to the scan in real time. In the scan view, you can now see the original scans and the aligned scans. The aligned scans were converted into a common coordinate system using a transformation matrix. The calibration files contain these matrices. Any shearing is corrected in addition to rotation and translation. With this calibration file, every further scan that is recorded with the same unchanged setup can now be transferred to this common coordinate system. All you need is a script which, in the first step, loads the calibration files and applies them to the scans. This means that the same result can be achieved without having to carry out the calibration again. Now we can place any part on the tray and both point clouds will align perfectly and can be used together.